now we want to talk about what are the forces that are acting on a nebula. And one of those forces is going to be gravity. Gravity is acting on you right now. Gravity wants to turn you into a black hole. It wants to squeeze your body, crush it, turn it into a black hole. So why don't you turn into a black hole? It's because there is some outward force that is keeping gravity at bay. Now in the case of you, it's the electromagnetic force. So the atoms that make up your body are being held apart and being held together by electricity and magnetism, so the electromagnetic force. And so that force is what's keeping the atoms apart and is holding gravity at bay. So stars are no different, and nebulas. So there are competing forces that are acting on a nebula. So one of them is gravity. Gravity's trying to pull the nebula in, turn it into a star, but then ultimately turn it into a black hole. So what could be some forces that are pushing outwards on this nebula that is keeping it from collapsing? Well, we've already mentioned one of them, which was thermal gas pressure. And so in this case, instead of having a blob of gas, we've got this box, and inside the box are gas molecules, and they're all moving around at different speeds. And so that is exerting a pressure outwards that is going to be keeping gravity at bay. Okay, the second thing is magnetism. And so I have a little video here that I'd like for you to watch. So MIT physics demo, forces on a current carrying wire on YouTube. So go ahead and watch that. I'll wait. Okay, did you watch it? Okay. So what you should have noticed is anytime that you got electrical materials that are moving, like the electricity was moving in the wire, then what it's going to do is it's going to create around it a magnetic field. And so if this thing has a magnetic field, and then you've got another wire that is carrying electrical current, it also will have a magnetic field that goes around the wire. And then depending on the direction of the currents in those two wires could be attracted to each other, or they could be repelled because of the force of magnetism. So think about what's going on inside this nebula. You have charged particles that are moving all around inside the cloud. And as they're moving around, they are generating magnetism. And so those magnetic fields of those various little particles could be interacting with each other. And so that could be another reason why the cloud does not collapse. Okay, the third one, we've talked about this one when we talked about the formation of the solar system. And we said that as a cloud collapses, first it turns into a disk, and then the disk is collapsing because of gravity, but eventually the disk is going to stabilize at a certain radius because of centripetal force. So centripetal force was this thing, so here's the formula for it. So its force is going to be equal to mv squared over r, where r is going to be the radius. And then v is going to be the speed of the particle. So as it's going around in a circle, it's got a certain speed. The particle has a certain mass, and the particle has a certain radius from what it's going around and around. So this causes a centripetal force. Well, the centripetal force is the reason why the particle is curving like this instead of going in a straight line. So this inward force is doing that. Now, if you, let's say that you're in a car and the car is turning because of this centripetal force, what do you do? So if the car is going in a straight line and then all of a sudden it's making a right-hand turn, you feel like you're being thrown outwards. So this is going to be called centrifugal force. And the centrifugal force is being caused by the centripetal force. Well, anyway, you've got all of these particles inside the nebula that are going around and around, and that could cause a centripetal force which could keep the cloud from collapsing. And then the fourth one is turbulence. So as you got all of these particles inside the nebula and they're all going in different directions, it's like they create winds. And just like that airplane is being buffeted by winds, you could also have winds inside of one of these nebulas, and that can keep it from collapsing. Okay, so let's take a break and let's talk then about why a star does collapse.